If you're looking to write your first machine learning program using Python in 10 to 15 lines of code, this tutorial is for you. In less than an hour, you're going to learn how to code and solve a real-world problem. We're going to start off with understanding the requirement in Jupyter Notebooks. Then we will jump straight into coding your first machine learning program. You will be writing a program to learn and predict house prices based on various inputs like number of bedrooms, square feet area of the house, locality, and more. So, by the end of this tutorial, you will get a very solid understanding of the life cycle of a machine learning project. You will not really need much background of AI, ML to do this example, but you should have some understanding about what is ML, where is it used, what are the types, etc. You're welcome to watch my video, a data science primer on my channel to get a hang of this. You do not need to be an expert in statistics, but any introduction to statistics will help. Again, you can watch some cool examples about hypothesis testing, law of large numbers, and more in a video I have uploaded on Introduction to Statistics. There is also a video on basics of Python, introducing numpy, pandas, matplotlib libraries and all. The links for all the three is in the description of this video. I am Praveen Kumar and I work on emerging technologies like AI, ML, RPA, hyperautomation, IoT, and I'm also an intraday trader. House price prediction is a very logical program to begin learning ML. Imagine the price of a house with 1,000 square feet against another house which is 2,000 square feet in the same locality. It should naturally be higher price. Again, compare one bedroom versus two bedroom in the same locality. Higher the square feet area, price is high. Increase the number of bedrooms, the price is increased. Are you getting it? It is quite linear. If it was so straightforward, why don't we simply use an Excel sheet and a calculator? The house price can be different based on other criteria too. In some cases, a one-bedroom house could be more expensive than a two-bedroom house due to the locality. To solve this problem, your conventional techniques or normal programming may get too complex with a lot of conditions and validations and rules. There may be other factors like the neighbor of the house is a Hollywood actor and the price shoots up. Therefore, we can use machine learning to solve such problems. I have been uploading dozens of videos on machine learning, deep learning, neural networks, which might be helpful to you. So be sure to subscribe to my channel. So let us start coding our first program in machine learning. So this will be a house price prediction program, and we will use Jupyter Notebooks for writing the code in Python. So first thing is open up Jupyter in your browser, and it will look like something like this, and it will be showing all the files you have under Jupyter. So first we will have to click on the new button, use Python 3 as your interpreter, and it opens up a new window with an empty Jupyter notebook. We will give a name for the notebook. We are doing house price prediction, so we can call it as house price prediction itself. So your empty notebook is ready. So we have the source data also in the same folder. It's under house_data.csv. This contains all the house data that we will be using for our prediction program. So to start the program, right, we will be requiring some libraries, and the libraries will have methods that we'll be using through the program. So let's import the libraries. There are three libraries which are important that we have to import. One is numpy, the other one is pandas, and we also need the matplotlib. Also, I'm using aliases, numpy as np, pandas as pd. This will be useful for writing code instead of writing the full name of the library. Okay, so numpy is used for numerical and arithmetic calculations. Pandas is used for working with data like data frames, data sets type of things, and matplotlib for charts and graphs. Right? So press enter, and then we will now see the data itself. We will load the data into some variable. These are the house prices which are in a CSV file that we just saw. Right? So to load and work with data, pandas has a very simple method called read CSV. Right? So I'll just say pd.read.csv and give the file name. It actually loads the data, but I'll have to assign it to a variable which is going to be a data frame. So let me call it house data. So house data equals pd.read.csv of the file name, right? Is the house underscore data.csv, which we already have. So I'm going to give that, and this command, when executed, will load all the data into the data frame called house underscore data. Notice that Python doesn't require you to declare a variable or anything. It just start using a variable as it is, right? Now that we've loaded the data, let's check, watch the data, what's in it, what was in the CSV file and all, right? So for that, there is a command called head. Head returns the first 5 rows of the data frame. So we can also change the number of rows returned. You can see here data, date, price, bedrooms, bathrooms, living square feet, and number of floors. All the variable things are there. And I'm going to now take 10 rows just by giving number 10 there. You can see there's 10 records that showed from the house data frame, right? There's 21 columns, and there were about 10 rows, right? Another command we can do with data frames is describe. This is good for data scientists and analysts, right? So you can see the count, mean, standard deviation, minimum value, maximum value, 50% value, all that stuff for each of the columns, like your bedrooms and bathrooms, square feet, basement, all that stuff that we have in the house data. Okay, so I'm just deleting that one extra line earlier that we had, just to keep space. That's just for description purpose only. So then comes visualization, right? A good data scientist needs a good visualization. You need to see how your data is related to each other, columns and all. So we will be using the matplotlib, right? The PLT is nothing but matplotlib alias. So we'll draw a scatter plot using the scatter command, and we'll have to pass two values to this, two arrays. The first one is on your x-axis and another one is on your y-axis, right? What we'll do here is we'll plot the living room square feet area against the price. Like if you have 1,000 square feet, the price is probably $200,000, right? If you have 3,000 square feet, maybe it is $350,000. So we'll see this visually using a scatter plot. So for that, yeah, the first value was square feet living, second one is the price, right? Okay, now let's press enter. Look at the power of Python, right? Look at the way it just loaded the data, displayed it so beautifully in one single line of code. I did not have to do much. Your pandas loaded the data, and then the matplotlib just showed the data. It's the beauty of it. Now you can also do bar chart, pie chart, different types of things just by calling one line code, right? I'm going to delete this. It's just for visual purpose. We will continue writing the code for your ML program. I imported the data, and now we are going to work with the data. So what to do in a machine learning program, right? We have to define what is our output, what is our input. We have to do training of the data and doing predictions and all. So let's do that step of figuring out what are the input columns and what are the output columns. So when we try to define the output, what is our output? What are we trying to predict here, right? In house price prediction, we are predicting the price of the house. That is the prediction. That is Y. So prediction or output is generally denoted by the letter Y, and the labels are also called as labels, and then the input data, right? The columns that are required for training, that is denoted generally by the letter X, right? I can say X is what? The whole house data itself, right? So that is X. Y is what? Y is the current value of the house prices. So let's define Y first. So it's simple, right? It's just the one column called price. So house data of price, that is my Y. That's it. That's one array which will pick all the values in the column price and load it into this variable called as Y, right? That's done. That's simple. Same thing for X. Instead of just one column called price, we will need all the columns in house data. So X is actually just house data, but remember that house data also has the column called price, which is not required because that is what we are predicting. And we also know that if you're looking at the image above, there is ID, there is date, which will not be useful for predicting the price. I don't need the ID of a house to find the price, right? We need square feet and all that kind of stuff. So let's drop those columns, right? I'm going to drop the ID column and the date column. Some data sets also has father's name, grandfather's name, or who bought this property first, who give a donation, all that stuff. So those when you have such data sets, you will have to drop those columns, because that will only kind of make it more difficult to do the predictions. That's not proper data. So we drop those columns, and to ensure that it is columns and not rows, I have to say access is equal to 1. So now we are setting up our input and output data. Very simple, 2 lines of code. Y is equal to house date of price, X is equal to the rest of the columns, right? So this is completing the next this main crucial step, right? So what we did was we loaded the data, we kind of curated the data. It's not full curation or pre-processing, but it's a little bit of dropping the columns and stuff. Now we are looking at training, right? We have to train the data that we loaded. We'll be using a linear model here. It's a linear regression. So for that, Python has this lovely library called scikitlearn. So we can use scikitlearn for importing the linear regression class, and you can create a variable or assign a simple variable xyz model or whatever. I'm calling it model here. So model is equal to linear regression. That's what I'm going to say now. Yeah. So this will create an instance of the linear regression class. Now if I compile this, it should ideally create the linear model variable into a linear regression class, but I think I've made a mistake there. It's from sklearn dot I have to use the model selection, right? Like which model that I'm going to do from. So yeah, let's just type that. I think it's linear model, sklearn dot linear underscore model import linear regression. Yeah, now it should work. Yeah, you can see that it's done. Cool. So we have chosen our model as linear. Similarly, you can use any other models like logistic regression or Bayesian or any other things. Okay, cool. Now we can split the data. So once we have our model ready, we will do training and testing data split. So this is a very important aspect in machine learning. You will not give all your data for training, right? Then it's like even the exam questions are given to a student. So I'm going to divide the data into training set and testing set. And to do this, our sklearn again has a beautiful class called train test split. It's a very powerful method, train test split. And what it does is it just takes the input as your X and Y. That is, what are your input features and what is the output label, that is X and Y. I will also have to define the percentage of test and train split. So there's test size. I'm going to give it as 20% here, 0.2. That's 20%. Right. There's another variable called random state. It's more like a seed. It's like initializer or randomizer or whatever that is. We can give 0.3, 0.1%. It's basically 10%, 20%, 30%, whatever we want we can give. So random state, well, you can choose any number. You can give 2, you can give 1055, whatever. It's just a initializer value. So this train test split, I'm calling the method, but it returns some values, right? So we need to assign the values. Now again, look at the power of Python. Most languages, we have always done a function returning a single value, right? Here, this method train test split returns 4 different arrays. It returns 4 values, and I'm assigning all of them in a single statement. Your X train, X test, Y train, and Y test. All these 4 are returned by one single command. And this is actually dividing your whole data set into training data set, testing data set. Also, it is dividing your training data set of inputs and training data set of outputs, and testing data set of inputs and testing data set of outputs, right? So once the split is done, right, now we have to do the training itself, right? The actual activity of the training. So the easiest, fastest, or simplest way of doing that is a single line of command. It's model.fit, right? It's very simple. So what we're going to do is we'll call the fit method on the model and pass the training data to it. So what is our training data? We have xtrain and then we have ytrain. So we could just call model. Model is the same variable that we have created earlier. So we say model.fit, right? And what do we pass to it? The training data, the xtrain, comma ytrain. So this is your training data set. That will be the some 18 columns of your data set plus one column price for ytrain, right? So what was xtrain and what was ytrain? It came from your original data set of x and y, which had everything, right? Your x was all your inputs, y was all your output. So that is coming again from your house price data, right? That's we had taken the price column and we had dropped the unnecessary column from the x, right? So that's what this is. Oh yeah, but let us also see how did the split happen, right? Let's look at the x train and y train. What's inside? Well, like what is the shape? How many rows and how many columns does it have? So Python has this very simple command called shape, which we can use. This should produce the output. All right, you can see 17,290 rows and 18 columns. So that is 80% of your test data, training data. We took it from the CSV file and split it into our train data. So that's 17,000. Now let's also check what's there in our ytrain array, right? The shape will now give an output of 17,290. You notice that there is no 18, 10, 1, 2 or whatever, because it has only one column. That's the price, right? That's your ytrain. xtest.shape will give us 20% of the overall data, 4,000 records. You can see that here. It also has 18 columns because it's input data. Then finally your ytest.shape also, so that is 20% of total input data. And now let's also print ytest.shape. It will be again, take a guess, 4,300 comma nothing, like just one column, right? So that's what it should be. Let us execute and see. Yes, it's 4,323 and one column of price. So yeah, so you can play around with all your train data, test data by using shape. There are many other commands. Python has some cool stuff for numbers, arrays, arithmetic operations, and all that stuff. So coming back to what we were doing earlier, we are calling the fit method on the model to train the model on this data, right? So we have xtrain and ytrain, the input and output of training data, and the model was empty, right? It had nothing. We are just calling the fit and say read this data, like a student is being told that study for exam, right? This is your book, this is your syllabus. So now the model has learnt it. It has given the output that linear regression, right? So it has learnt already. Now your model is able to understand. It went through those 17,000 records and said, hey, this is how your inputs are and this is what your output is coming. I'm able to crack the code. I'm able to understand how, right? So now that model is trained, we should start testing the model, or we should test the model, right? Or scoring. It's like after the student gives an exam, we will go through the answers and do a correction. So how does it test? It takes the 20% of the records, and instead of using the actual value of price, it will predict the price and compare it with the actual output and checks how many times it worked. So model.score, just one single line of code, xtest comma ytest. So I'm going to now execute this and it should give us the accuracy of the overall model. So yeah, you can see it's 0.7156, that's 71.56%. So 71% is good. At 71% of the times it is able to predict the house price. Very pretty not it's not very accurate, but it's accurate. Accuracy is decent, we can say. This can be improved to like 80-85% by choosing other algorithms, by doing better calibration of your data. That's where the domain aspect comes into picture. So yeah, by training the data and testing the data, we achieved about 71%. And how does this model now work, or how can we use this? there is a model.predict command, right? In future, if you get a new record, if you get input data of a house, like there's a 3-bedroom house which is 3000 square feet, it is in this locality, blah blah blah, you will be able to just send the data and it will come up with the predicted price. It says this house is going to cost you $300,000, right? Now I'm going to remove some extra lines of code which was not useful for actual prediction. Let's look at the overall code. What we did, we imported the libraries. It's numpy, pandas, matplotlib and all. That's the 3 important libraries for our machine learning program. I did not do anything big. Pandas was what was heavily used, mostly for data frames. Then we also tried doing the scatter plot. We can try bar chart, pie chart and all. That's all the matplotlib library. Then what we did was we loaded the data, right? House data.csv contained the data. We used pandas.readcsv and put that all into a data frame called house data. And then we defined what is our input data and what is the output data. And X contained all the columns except price, ID, date. Y is just the price. Then once we had the X and Y data, we have to train, right? And for that we used a scikitlearn linear model. In that specifically we are planning to choose linear regression, and we have a variable called model. It can be XYZ, ABCD. You can give whatever name you want, but yeah, we'll keep it as model itself. It's more readable, and we use the linear regression method. That's the initializing it. Then we did the split of data, training data and testing data. And how did we do that? It was a very simple train test split command available from the train test split class in the sklearn model selection, right? So what does it do? It takes inputs of X and Y, and then it returns your X test, X train, Y test, 4 different arrays. We also used 80-20% for train and test data split. That was 0.2. And then after that our next step was to call the fit method to fit the data, or like do the training of the data. Basically your model learnt all the data just by this one single command, model.fit, right? It's able to predict based on that only in the future. Now we have to ensure that the training was done properly, right? How well did the student study the class? That's where you do the scoring, model.score, X test and Y test. That was the 20% data we had kept aside. So it was hardly very small, simple program. 1, 2, 3, 4, 5, 6, 7, right? It's just 7 lines of code. I wouldn't say 7 lines, about 7 pieces of code, maybe 10 to 11 lines of code probably, in about 7 steps, right? We were able to create your first machine learning program which is now able to predict house prices by giving input data, and your input data is all your number of bedrooms, square feet, area and all that kind of stuff. It's very simple, very easy. Look at the number of lines of code, it's so small, and machine learning is not difficult at all. That's what I want you guys to say. Yeah.